we go over the Moivres theorem. Now we know that if we've been given z1, let's have been given z1 which is equal to r, and then we have got cos theta plus I sine theta, and then you have got z2 which is equal to r cos theta plus I sine theta. We know that when we are multiplying two complex numbers, z1 z2, what we do is we are going to first multiply the r's. Now in this case, if we've got the same r, then that is going to be r squared. And then the next thing that we do is we get cos. We are going to get this angle and then add it to this angle. Now since these are the two angles which are similar, that will be theta plus theta, that will give us 2 theta, and then plus I, same with sine, the angles are the same, so that will give us 2 theta. Now assuming you've got another complex number z3 which is also the same as this, so let's say this is z3. Now you are multiplying now this result z1 z2 by z3. Again you get just this, you multiply them, that is going to give r to the power 3 if they are the same, and then you have got cos 2 theta plus theta, that is going to give 3 theta, and then plus I sin 3 theta. Well, this is telling us that if you have got a continuous number of times, we continue doing like this, depending with how many things that we have multiplied, that will be the power. So if there are 4, then that will be power 4, and then there will be a 4 here. If there are 5, just like that. So it is from here that we even get if we are squaring a complex number. So if you've been given z1 like that, now if you say z, or let's just say z, if you raise it to the power n, then what you do is just get r, you raise it to the power n, and then that will be cos. Now this will be n theta, and then plus I sine n theta. So such an expression we can see here is what we call the Moivres theorem. So if this was to the power 2, then that would be a 2, that would be a 2, and that becomes a 2. Okay. Now let's look at some things about the Moivres theory. We see how they are applied and how we are able to simplify them. How can we simplify some complex numbers using the same de Moivre's theorem? Alright, so let's consider a complex number which is the root of 3 plus, let's say, minus I to the power 8. Now say they are saying express it in the form a plus ib. Now how do we go about it? Well, the simplest way to do this is to convert it into polar form and then use the Moivre's theorem. Times it might not even be stated use the Moivre's theorem, but you need to get to know what can I use for me to make this thing simpler. So let's just get first what is inside. So the root of 3 minus I. So let's convert this into a polar form. So first we are going to find r, and we know that r is given by, you get x and y. So x is root 3, you square that, and then plus negative 1, the number in front of I, squared, and then do square root. Now root 3 squared is a 3, and then negative 1 squared is a 1. 3 plus 1 is a 4, so that would be root 4. Root 4 is a 2. And now we need to go to theta. So theta is given by tan inverse y over x on complex numbers, just like we do even on vectors and projectile motion and just everything else. If you know the components, you can find the angle. So y, this portion which is having in imaginary part is the y component, that is a negative 1, and that is divided by root 3. Well, if we consider on this triangle here, 1 here, this is root 3, and then this is a 2. This is 60 degrees, this is 30 degrees. This is these are special angles. We know that tan is opposite over adjacent, so we want the opposite to be 1. So for the opposite to be 1, should be this one, and then it should be adjacent. Then the angle we are referring to is 30 degrees, because for 31 is the opposite, and then root 3 is the adjacent. So tan inverse of negative 1 over root 3 is supposed to give us 30, and in that case it's going to be negative 30, because we're talking of a negative value which we have at that point. So then theta is going to be negative 30. Now 30 in radians, that's multiplied by pi over 180 degrees, so that will be negative pi over 6 radians. And so what we can see is this complex number, we can write it in the form r cos theta plus I sin theta, like that, where r is a 2 and then theta is negative pi over 6. Of course, we can write it to a positive form, and know that negative pi over 6. First, a complex number, in which quadrant is it? X, we can see x is positive, y is negative. So it is in this quadrant, it's something like that. So where this is 30 degrees. Now, if you want to get the positive version, you're supposed to take this angle like that. So to this angle, we're supposed to add 360, which is 2 pi. And that is going to give us 2 pi minus pi over 6. What are we going to find even? So that is going to give us something like 11 pi over 6. Anyway, we can also use just the negative one as they've given us. So we'll go on and express that into polar form, and so we'll say this is our r is what? Our r is a 2, as we saw. So that is 2, and then cos the angle is negative pi over 6, and then plus I sin negative pi over 6. And then the whole of this thing, we are raising it to the power 8. So that is the power there. Now, we can go on and work with what we can see here. Now, how do you work out this? So if we have got something like that where we've got a power, if we raise something to a power, according to the Moivres theory, we'll just get this, raise it to the same power, so that will be 2 to the power 8. Okay. And then that will be cos this angle, we're going to multiply it by the 8 as we saw. Remember, the form is r to the power n cos, this is cos n theta plus I sin n theta. So this n is the power which we are multiplying with the angle that we have, so that will be cos. Now what is the angle that we have at this point? First, we have got 8 times the angle is negative pi over 6, and then plus we have got I sine, still we have got 8 times the angle which we have is negative pi over 6. Okay, so that is what we are going to have. Now let's go on and simplify. 2 to the power 8 is 256. That is 256, and then we've got cos. Now we can multiply these, which we can see there. A 2 can go here, 3 times a 2 can go there, 4. So that will be cos negative 4 pi over 6. Okay, like that. And then plus I sine. Inside there it is also negative 4 pi over 6. So that is it. Now our aim is just to find cos of that, that is not over 6, that is supposed to be over 3. I've realized, because we are saying 2 into 6 and 2 into 8, so that is a 3. Even at that point it's a 3. Well, if we talk of negative 4 pi over 3, let's try to convert it to degrees. In degrees, things are simpler to work with. So we multiply by 180 over pi. So we can see that the pi is going to cancel. And 3 into 180 is 60. And 60, we are multiplying it by 4. That is 240. So that is 240 there. In which quadrant is this 240? So this is 0, this is 90, this is 180, this is 270. So 240 is going to be in this quadrant here. So this is our 240 degrees. Now I want to find the angle that is related to the x-axis. So this angle. So what will be that, and how do we find it? Well, we'll just say 240 minus 180. And that is going to give us a 60. So this is 60. So what we are saying is, now in this quadrant we need to get the sign. We have got all students take coffee, like that. So the sign for cos here is negative, and then the sign for tan, for sine, is also negative in that quadrant. Okay, that is what we need to get to know. So that is 60 that we have found at that point. Now, of course, what is cos 60? Cos 60 is 0.5. And if we multiply that 0.5 times 256, supposed to get 128. So in other words, the angle which we have there, the negative. Now the meaning of a negative there means, instead of us moving like this, let's see what that means. Because mostly in many exams, such questions will not require a calculator. So because the angle is negative, then we are taking the other way. So we're going to take this as 0, then this is going to be negative 90, this is going to be negative 180, this is going to be negative 270 degrees. And so the angle is going like this. And so this negative 240 we have found is going to be in this quadrant. And so this is going to be 60 degrees here. Okay, like that. Now in this quadrant, we know that sin is positive in this quadrant. But for cos, of course, we know that it is negative. Well, we're going to go on and just work with the 60 there. So if we punch on the calculator cos of negative 4 pi, let me use degrees, that is negative 240, that is negative 0.5. Just as we know here, it is only sin which is negative. So if you are using something that is negative here, then obviously it's going to be negative when you are dealing with cos. So this is going to be 256 cos negative 4 pi over 3. We can also write this as positive. Okay, we can say cos. Now this angle can be written as a positive angle, but that is positive what? 60 is the same as pi over 3 in radians. Now we are putting a negative here. Why are we putting a negative? Because in this quadrant which we have found, cosine is negative. That is why we are putting a negative. And then that is going to be now plus, of course, negative 4 pi over 3 is the same as, we can use this special angle which is 60. I sin 60 is pi over 3. Now for sine, we are only going to use a positive. Why are we using a positive? In this quadrant, sine is positive, whether this is negative or positive. Okay, as long as it is finding itself in the second quadrant. And we know that cos 60 is what? Negative 1 over 2. And then sine 60. Okay, Sine 60, if we check on the special angles, this is root 3, this is a 2, this is a 1. 60 degrees is at this point. Sine is opposite over hypotenuse, so it is root 3 over 2, but there's an I there, so I'm supposed to put that. So if we do multiply negative 1 over 2 times 256, that will give us negative 128, and then 2 into 256 is 128, but we have got a root 3 there and an I, so we have written it in the wanted form, in the form a plus ib, where our a is negative 128 and then our b is 128 root what? Root 3. So that is the answer for that one. Then that is basically how we do. So we just need to know how to apply the de Moivre's theory, and then we are going to be able to work out, doesn't matter the power that you have. Alright, let's consider some other problem. We've been given to use the de Moivre's theory to evaluate. We have got negative 1 plus root 3 I to the power 12. So now how do we evaluate such a problem? Well, to evaluate, what we are going to do is we are going to convert into polar form. So we are going to first find theta of what is inside there. How do we find theta? Theta is given by tan inverse y. Now our y is this portion, that is root 3, and then our x is negative 1. So this is simply tan inverse of negative root 3. Now tan inverse of negative root 3 is negative pi over 3. We can work with this angle, or let's convert it to the positive form because it's better to work with positive values. So the angle that you have found, if you look at this complex number, x is negative, y is positive, so it's going to be in the second quadrant. So the angle that you found is here, pi over 3. The reason as to why it's negative is because it's going like that. So I want to find it starting from the positive x-axis in that manner. So that is what we want to find. So all we do is to this angle we're going to add pi. So that is going to give us 2 pi over 3. Now again we need to get the value for r. R is given by negative 1 squared plus root 3 squared, and then we do square root, and this is going to give us a square root of 4, which is equal to a 2. So let's keep the two values, and so we are saying this can also be written in the form r. Our r is 2, and then we have got cos, the angle is 2 pi over 3 plus I sin 2 pi over 3. Now this is raised to the power what? To the power 12. So that is the same thing that we have done there. Now at this point, using the de Moivre's theory, can get this, it becomes the power, and then this same thing we're going to multiply with the angles which we have, and so that is going to become 2 to the power 12, and then you have got cos, this 12 is going to multiply 2 pi over 3, and then plus I sine 2 pi over 3. This is also multiplying with 12, so you don't need to forget that. So this is going to give us 2 to the power 12 cos 3 into 12 is 4. 4 times 2 is 8. That is going to be 8 pi plus I sine 8 pi, like that. Now just looking at the first angle which we add, even before multiplying by 12, that angle, if we convert to degrees, it's going to give us what? That is 270 degrees. Now if we look at a sine graph starts from 0, it goes like that, and then it comes back at this point, where this point is the angle here is 90 pi over 2. This point is a 1. The angle here is 180, which is pi. This point here is at okay, 2, that is 3 pi over 2. Now this is 2 pi over 3. Let me convert that to degrees. Perhaps it's not 270 degrees. So that is 2 pi over 3. We are multiplying by 180 over pi. So 3 into 180 is 60. 60 times 2 is 120. Okay, I think that's the value. Now let's go on and punch on our calculator. What would be cos 8 pi? Well, if you are just talking of pi alone, cos pi, if you have got a cosine graph starts from the maximum point, so a cosine graph is going to start at this point and then take it like that and then like this. So where this point here is a negative 1, so now we are talking of cos 8 pi. So cos 8 pi, so cos 8 pi is a 1. Okay, just like this one, this point here is pi, positive. So if we say cos 8 pi, that is going to give us a 1 anyway. We found that. That is 2 to the power 12. And that is given us a 1 plus I. Now let's press sine 8 pi. That is going to give us a 0. So there is a 0 there. So this will just give us 2 to the power 12 as a value. So we express it in the form a plus ib, where b is 0, so it just remains as a. So that is how we use the Moivres theory to simplify even such questions. Now let's look at another form. We see how we are able to simplify. Well, if you've been given, say, cos 7 theta plus I sin 7 theta, and then what you want to do is this is divided by cos 2 theta minus I sin 2 theta. Now we want to simplify this one using the Moivres theory. Well, when you are using the Moivres theory, you can see the one which is on top here, that we have got a 7, also have got a 7. So this should tell you what that means. So if you've got numbers at that point, this should tell you that R was 1. And we said 1 to the power 7 is simply 1. That's why we can't even see it. Okay. Now a complex number is in the form R cos theta plus I sin theta, like that. But here we have got a negative here. Well, where does that come from? We need to get to understand that cosine of negative x is equal to cosine of x. Cos from this tells us that it is an even function. What we mean is if we use a negative angle or you use a positive angle, it is all going to be the same. But sine is an odd function. So if you have got sine of negative x, it's just saying negative and then multiply with the sine itself. So sine is an odd function. So we can use this same manner to go there and input. Okay. So this is going to give us cos 7 theta plus I sin 7 theta and then divided by. So cos 2 theta can also be written as cos negative 2 theta. We know that is the same thing. Now negative I sin theta, instead of having a negative here, we can make that negative to be inside and then that to be positive. We know that from sin because sine is an odd function. So if we write like this, is the same as writing a positive angle and then putting a negative here. So that is the same thing. Well, from the Moivre theory, we know that if we got this thing here, that means this should have been in the form cos theta plus I sine theta, and then that was raised now to the power 7. Okay, and then the other one, now we can see the angle is negative 2. That negative 2 should tell us we have something like cos theta plus I sin theta. It was raised to what? To negative 2. So that now, to simplify, we brought this negative 2 to multiply with the theta there at that point. Well, at this point we can now go on and say cos theta plus I sin theta. You've seen that you have got same bases on top and down. Same bases dividing, we subtract the powers, so that will be 7 minus negative 2. And this is going to give us cos theta plus I sin theta. That is going to be raised now to the power 9. Now at this point we can bring down the 9 then, so that will give us cos 9 theta plus I sin 9 theta from the Moivres theory. So this becomes the simplified form. Alright, thank you so much. Stay blessed.